Hey Codesies, welcome back. Today, we're diving into prompt evaluation. We'll learn how to systematically check if your prompts work well and how to make them even better. This is key for getting consistent, high quality results in any business. Why evaluate? Simple. In businesses, you need reliable AI. Randomly changing prompts won't cut it. Systematic evaluation means you know what works, why it works, and how to improve it. This saves time, money, giving you better AI outputs. Feedback loops involve collecting both qualitative and quantitative data. Qualitative means user comments or observations. Quantitative means measurable things like accuracy scores or how many times a prompt gives a good answer. Both help you understand performance. Now, A/B testing. This is a powerful way to compare two or more prompt variations. You run different versions of a prompt, measure their performance, and see which one is best. It's like trying two different recipes to see which tastes better. Sometimes when you chat with ChatGPT, for example, it actually asks you which answer do you like best and lets you choose between two or more answers. This is A/B testing. Now, when you do A/B testing, you can compare prompt versus prompt, like have two versions of a prompt and try to compare the results, or model versus model, where you have the same prompt but use two different models and see what works best for your specific use case. Now, to measure, we could measure accuracy, completeness, or tone, but they all require ground truth. And ground truth requires human labeling in order to compare the model's outputs with the human label. Not all of us have the resources or human power to do that. So, what most people do in order to make this automated as well is they have a thumbs up and thumbs down buttons that we can use to compare the output and pick the best version going forward. After running tests, you compare results. You're looking for a clear winner. Sometimes the difference is small. That's where statistical significance comes in. It helps you know if a difference is real or just a random chance. We won't go deep into stats, but know it's about confidence in your results. Alright, so now let's actually take a look at some tools that are used to evaluate models. Now, there are some tools that are used for coders or developers, and some tools that we're going to explore with that don't require any prior coding experience. First of all, if you have some prior coding experience, I would suggest you take a look at Langsmith evaluation or TrueLens. But for the sake of the current demo, we're actually going to take a look at the evaluations in the OpenAI's Playground, which is amazing, by the way. Here, where we used to create our own prompts, play a little bit with the temperature in the OpenAI's Playground, is we're going to take it a bit step further and go to the evaluation part, where you can actually upload a data set. It will ask you for the dataset and the prompt. So we have to create both together right now in order to create an evaluation. You could actually just upload the dataset and it will be uploaded in the datasets here. Now there's a ton of datasets you could use. For the sake of the current demo, we're going to use the MMLU dataset, which is a measuring massive multitask language understanding. So it's an awesome dataset. It's open source. So let's take a look at it first. It basically has the question, for example, those questions that are related to abstract algebra and some choices that they can choose from. And it will basically determine how much they understand of that question in order to answer correctly. And the answer is right here. Now I will go to the abstract algebra and just download the test dataset right here. So I downloaded it and converted it from Parquet to CSV. Parquet is another data format that we're not going to talk a lot about, but it's very similar to CSV and can safely get converted to any of those. If the OpenAI's Playground accepted the Parquet, we could have just uploaded it, but unfortunately it just accepts CSV or JSON-L. So we're going to actually go back and download it and then convert it to CSV. And then since it's actually 100 records, I'm only going to take the first 10. Now this is how it looks like. Question, subject, choices, and the answer at the very end. And I just took the first 10 lines of the dataset. Now this is what we're going to upload. So I went ahead and uploaded it. It says 10 rows, which is what we want. Question, subject, choices, and answer. That's all we need. You could just remove the subject since we're just doing the abstract algebra. I'm just going to keep it. And you could just name the dataset something. I'm going to call it MMLU, and I'll just hit create. All right, now the dataset has loaded. Now we can see the data right here. Question, subject, choices, answer, and output. This is the modeled output. It didn't actually run yet. And you could compare prompts together, or you could compare, like, I can just have a new prompt in here. Or you could also compare models, like have the same prompt and use a different model, right? Now, right here, we could just create a new prompt, or if you already have some prompts that you created from the chat page, you could just import it here. So we're going to just do our own prompt. I already have it somewhere here. All right, so let me just copy it. I'm gonna paste it here. This is the first prompt we're gonna do. This is the very simple prompt that should be just outputting only the number or the answer directly, without any thinking, without any COT or chain of thought like we've learned about before. So this is the user prompt. Right here we have the question, subject, and choice. Of course, you can remove the subject because they're all the same subject. I just give it the subject just to give it a hint of what this question is about. And of course, don't give it the answer because you don't want to help it cheat. Now, every single time it runs, every single one of those is going to put the question in here, the subject, and the choices in those variables. You can see all the variables available from this variable button. I'm just going to scroll up there before I save and change the model to 4.0 mini. Maybe tone down the temperature just a little bit. Yeah, 0.3 is fine. Let's just even do 0.2. And we're going to go to the very bottom and just save. You can name this prompt whatever. I'm going to just call it MMLU, just because it's the same MMLU prompt. All right, now this is version 1 of the prompt, and it has already been saved in here. So if I go to create a new prompt, I can just get the same MMLU1. And if you update, it's going to change the version from version 1 to version 2, etc. Now let's just take a look back at this prompt that we have here. I'm going to generate the output. It's just going to run all of those and just see like how the output looks like. So the 1, it actually got it right, got it as 2, even though it was 3, etc. So some of those are correct, some of those are not. We're going to add a grader in order to grade this. You can use a scoring, and this is when you don't have ground truth. Like you want to give it, like use another model to just take a look at this and score how you would score it. Or we could just compare if we have some ground truth, right? We can select the ground truth is going to be the answer column, and we could either use a model to score it, to compare it, but if the answer is quite simple, we can just do string check. It will just compare this string, like the answer, to the output, and if they're the same or not, right? In our case, it's quite simple. You might need to use an LLM comparison if the answer is more like an essay and you want them to take a look and grade however a teacher would grade them. Now I'm going to do string check because the answer and output are very simple enough. There is more graders that you can use. The string check is what we use here. Text similarity, like how similar the texts are. If it's more than the threshold, is going to be accepted, less than not. Model labeler, if you have a model that labels things, you're going to use your own labeling model to correct things. And the scorer, if you have a model that scores as well, and a Python grader, which we're gonna explore as well, like sometime soon. But yeah, for now, let's actually save and run. It's going to run the comparison and just check. Oops, it does this to me sometime. I'm not sure why. So I'll just wait for a few seconds and then refresh the page, and hopefully my gradings are gonna be there. All right, so now I've actually refreshed the page and it's actually done. If you have more of them, you might need to wait a little bit longer to refresh. I know it's a bit of a annoying bug, but it works. If you just refresh too early, you might lose your comparisons and you might have to re-compare again. Anyways, now that I have the grading, it says 50%, which actually isn't bad. You might think that 50% is just like a random chance, like it's randomly answering, or it's a 50-50 chance. That's not true for this case. It might have been true if we only had 2 choices, but I can see 3, 4, sometimes 5 choices. So it has a direction and it knows where to answer or what. If it actually was answering randomly, it would have been like a 25% or a 20% chance. But here it says 50, which it kind of knows how to answer. It has a little bit of a guide on its own. Now let's actually create another version of that. So this is the same thing. I'm not going to update any of those. I'm just going to update the prompt. Be careful when you're doing A/B testing. You only want to change one thing. If you change 1 or 2 things, you're not going to know which is doing the good or bad effect. So you might need to just change one thing at a time and then compare. So I cannot change the model and the system prompt. I'm only going to be changing just one. just to know if this system prompt is doing better than the other system prompt. And then later on, once I get the results, I'm going to compare the models in a different trial where I only change the models but keep everything else static. Now let's actually use the second version 2 prompt. Copy and paste. I might just have them in the chat as well for you guys. Now that I have this other one, it actually uses a scratchpad, closes the scratchpad tag, right? And it just gives you the answer right away. So the output of that would be a little bit more complex, not just simple answer. Let me just generate the output for you, just for you to see what I actually mean. While we're at it, I'm also going to click on the update just to create a new version and save that version as well. Awesome. Notice how this is updated to version 2, but this still is version 1, right? Now let's actually take a look at this. And now let's take a look at this, for example. Now it has a scratchpad and then says 1 instead of just saying 1. So the normal like string comparison is not going to work. If I try to grade it how I was grading it before, like comparing the strings, it's totally not going to work. They're all going to be fail just because the answer is at the very end of the output, not the whole output. So we're going to do Python grading for that one. I'm going to click on grade and then add create grader. And then we're going to do Python grader and I'm going to paste the Python code to grade them. All right, so this is the sample code. I'm going to replace it with this code. That's going to search for the closing of the scratchpad and just get the text after it. By the way, if you don't know how to code, there's no problem, no issue. All you need is just copy this source code, paste it into a good LLM, and just ask it to grade it however you want. Just show it the output example and the answer, and then it will do the job for you. So you don't have to be the best coder in the world to be able to do that nowadays. I'm going to save and run. And now it's going to do a little bit differently than the 0% comparison of the two strings. Okay. All right, now we got the answer. It's 0.60 or 60% is way better than 50%. Like the 60% is just way better, right? Now, if you think about it, this 10% might be just by chance. But if you just do it on, like, I would recommend you do it on a longer data set. So let's just say you have 100 records. Now, the 60% doesn't mean that there's just one that was accidentally answered correctly, but those 10 that actually got answered correctly. So you would actually know for a fact. I would recommend you have a big or a very long or a bigger data set, especially if you're doing it on production data and you're going to put this model or prompt in production. Now I'm going to just save. Now it says it's saved. We're going to go back and we're going to see it in the evaluations, data sets. You can just click in here and just go back. And yeah, that's it. So, evaluating prompts with feedback loops and A/B testing helps you build better, more reliable AI applications. Hope you learned something new today and see you next time.